Hi everyone, my name is Olivia Atlas, and we'll be going over behavioral readiness for clinical AI deployment. And this will be shifting EHR deployment from reactive to predictive before patients are affected. So, right now, healthcare systems are rolling out AI, but they don't actually know if their people are ready to use it. So, we assume readiness, but we don't actually measure it. Over here, you'll see that with the VA, with the VA's rollout, there has been over 800 major performance incidents since launch, as well as more than half of their staff stating that it actually increased patient risk. So this isn't new. This isn't an issue with the technology, but more so how we're deploying it. For this slide, it really shows the disconnect. They had high training completions, which was over 90%. So everything on paper looks fine, but it clearly isn't. There has been multiple pauses within their deployment rollouts between in the years of 2021 and 2023, as well as serious issues that are still happening today. So training completion doesn't equate to real readiness, and the biggest gap is there isn't a real system today that can actually track clinical readiness. So, why does this matter? This isn't just a rollout problem, it's a patient safety problem. Clinicians are unprepared for AI assisted ordering, documentation. They're having to deal with alerts, complex systems, and that is a lot of pressure on their part. Also, leadership is making decisions without real evidence, and they're basically guessing, so that's where the real risk comes in at. And that's how you end up with both safety issues as well as operational problems. So the goal here is pretty simple. Instead of reacting after something goes wrong, we predict risk before we go live. We measure what people actually are doing and not just whether they have finished their training. And we also give leadership something that they can actually stand behind. So this is just a snapshot of a normal clinician workflow. It's nothing too crazy, just logging in, reviewing information, placing orders, and responding to alerts. But the real issue here is is what's happening in each step. There's friction everywhere, too much information, confusing systems, as well as alert fatigue. So that does build things up, and by the time that something does go wrong, it's not really a surprise because it's been happening the entire time. So I wanted to ground this on the interviews that I've had with Sarah, who is in a leadership position. So she needs to make a decision that she can actually defend in front of Congress, as well as Michael, who is a clinical implementation lead, and he's on the ground and he needs to know who's actually struggling. So right now, neither of them has a clear answer, and they're both working off of incomplete information. So what is the solution? So here is where AIGRC VET comes in. And it's basically a behavioral readiness system. So it looks at how people actually interact with the system and just not check boxes. Then it turns that into a readiness score and a risk signal. And from there, it gives a clear recommendation on whether leadership should go, do a conditional go, or a complete no go. So, how it works in three simple layers. First are the early signals, things like training activity, system usage, as well as their tickets. Then, second, we turn that into a readiness score. We can actually see the performance gaps and even detect people who are struggling quietly. And third, we will convert that into a risk score by leadership so they can use it to make a decision. So basically, we're turning behavior into something that's measurable. So, what changes is the system. We stop guessing, we actually measure the readiness, and the decisions become risk based instead of assumption based. And deployments become more controlled instead of reactive. This scenario is triggered by a scheduled AI system rollout at an existing hospital. So, 2 weeks before the system will go live, Sarah is responsible for making the final go or no go decision. So she needs to determine if the workforce is truly ready before the system is activated. But instead, the system will flag a low readiness score, and not just that, it shows exactly where the issue is, so she's just not guessing anymore. She actually knows what the specific problem is. So, based on that, the system recommends a no go. And this is important because it's not just a feeling anymore and is backed by actual data, documented and tied to specific risks. So instead of pushing forward and hoping it works, leadership can pause on that with complete confidence. So, what happens next is the system doesn't just stop risk, it guides correction and enables a safe rollout. So, the system doesn't just stop the things, it fixes them. Instead of retraining everyone, it targets the specific issue. The performance improves, readiness goes up, and then deployment can move forward safely. And instead of saying, oh, excuse me. So, with that, there will be a reduced post launch of incidents and it'll be more controlled as we address the risk early. Excuse me. So, from a business perspective, the value is pretty clear. We're preventing risk before deployment and not after. Customers are healthcare systems as well as the government and EHR vendors. And revenue comes from pilots, subscriptions, and integrations. What makes this different is it combines two ideas. So it would use Duolingo, which measures behavior very well, and but that's not necessarily built for enterprise decisions. Palantir handles complex data, but it doesn't measure the actual readiness. But using both these will actually help govern decisions. So, at the end of the day, it's really about just one thing, which is not making deployment decisions based on assumptions, and it should be based off of evidence because the real goal isn't just to react to failure, but it's to prevent it before it actually happens. Thank you.